to remind you, if you have X, Y, and Z, and you have applied force, whatever the direction of F, with angle between F and X-axis called alpha, and another angle between the force F and the positive direction of Y called beta, and a third angle between the force and Z axis called gamma. We learned that if you would like to convert this force to be a vector, so we will have F cosine alpha in X direction plus F cosine beta in Y direction plus F cosine gamma in Z direction. So we have three components. And also we learned that we have a relationship between these angles, cosine square alpha plus cosine square beta plus cosine square gamma equal 1. First step or first condition. Second one, if you have a force, first we have X and Y and Z, and we have a force F between this point, coming from this point, point number 1, to this point, point number 2. X, Y, Z coordinates for point 1 are known. X, Y, Z are known for point number 2. So I can say this force as a vector equal this force as a value, second point minus first point. So x2 minus x1 I, y2 minus y1 j, z2 minus z1 k. Divide this number square under square root plus this number square plus this number square. So I can finally convert this force to be a vector. We have a component in X, another component in Y, and third component in Z. We have third condition, which is need more attention for this one. We have X, we have Y, we have Z. And you have a force like this one called F. And this F has projection line like this one. This called projection line. So given this angle, for example, alpha, and we have another angle between the projection line and, for example, x-axis beta. So this line can be called projection line. In this case, please try to make sure, are you in this situation or are you in this situation? In this case, your angles alpha, beta, gamma between the force itself and x-axis, y-axis, and z-axis. In this case, the given angles, no. The first angle is okay between the force and z. But the second angle between something called projection line and x-axis. Same issue all the time. Okay. So first step, do you remember? We need to break this force first between z-axis and projection line. One of them will be sine, one of them will be cosine. We know the adjacent component will be the adjacent component to the given angle. Here is the given angle. So the adjacent component will be Z. So this one will be F cosine alpha. And the projection component will be F sine alpha. Then, second step, we need to break the projection component to X and Y component. So this one will be broken to this component and this component using this angle. Which one will be sine? Which one will be cosine beta? The adjacent component to beta will be cosine. So this one will be cosine beta. So this value, which is F sine alpha, will be multiplied by cosine. And this value, which is F sine alpha, will be multiplied by sine beta. So finally, this force has X component equal F sine alpha cosine beta, has Y component equal F sine alpha sine beta, and Z component equal F cosine alpha. We covered all of this material last week. Until this moment, do you have any question? Until this moment, do you have any question? What is your question, Bishel? Okay, yeah, I'm trying to go through the homework a little bit, guys. For F1, for question number 2 in the homework, we have F1, F2, two forces acting on point A, and the resultant force equal negative 100 K. So resultant force R is given as a vector. As a vector? Yes. Which vector? You have 0, I, 0, J, and the negative 100 K. Wow. So this value represent minus 100 K. Yes. K means Z direction. So we have I in X, J in Y, K in Z. So the three components of the resultant force are given 0, 0, negative 100. F1 is given 60. F2, nothing is given about F2, nothing. Because the problem asked for magnitude and the direction coordinate angle of F2. So we learned when we start this course, first step, we have to break each force. Okay, let's start with F1. I believe F1 looks like the third situation, this one. So we have here projection line, and we have here Z-axis, which is negative. So first step, we need to break this force between Z-axis and projection line. I believe in the Z component, Z direction will be 60 sine 50. And the projection line will be 60, the force, cosine 50. Here is the angle I'm gonna use. This angle is adjacent, or I'm sorry, the projection line is adjacent to this angle. So the projection line component will be cosine, and the component will be sine. Sine what? 50. Second step, we need to break this projection line component, this value, to y and x using the second angle 30. I'm sorry. Using the second angle 30. So we have 60 cosine 50, which is the value of the projection line, sine 30. We have 60 cosine 50 cosine 30. So for f1x, f1y, f1z, I can get these components. For f1x, I believe it will be negative 60 cosine 50 cosine 30. Normal, nothing new. For y, we have positive 60 cosine 50 sine 30. For z, we have negative 60 sine 50. Any questions so far? Any questions so far for the resultant force is given? Probably in the third problem, resultant force is clear, negative 300, positive 650, positive 250. This is the resultant force. Resultant force as a vector means the three components, the x component, y component, and z component. I started to break each force to three components. I started with F1. Any questions so far? Okay. What about F2? Just for your information, if nothing given about the force, if nothing is given, like F2 here, nothing is given. The value or the angles or anything related to F2, nothing is given. Please go ahead and assume this force as a vector equal fxi plus fyj plus fzk. Go ahead and assume a vector for this force like this. If nothing is given about this force. So we have fx, fy, and fz. Finally, summation of all x component equal x component of the resultant. Summation of all x component for the forces equal x component for the resultant. X component for x for F1 negative 60 cosine cosine. X component for F2 is Fx. What is the x component for the resultant? It's given. How much? 0. 0. So equals 0. The only unknown in this equation is Fx. I can figure it out. Summation of all y components of the forces equal y component of the resultant. So we have here y component 60 cosine sine. We have here y component for F2, which is Fy, equal y component for the resultant. What is the value of y component of the resultant? It's given, 0. So I can figure out the value of f of y. Then summation of all z component for the given forces equal z component of the resultant force. we have here in the direction, we have negative 65. Sine 50. We have from F2, Fz. What is the Z component of the resultant? It's given. How much? Negative 100. Please don't forget negative. Negative 100. So negative 100. The only unknown in this equation is Fz. So I can figure out this value. Okay, go ahead to find this value. It will be 60 times cosine 50 times cosine 30. This value will be positive 43.6. This one will be negative 60 times cosine 50 times sine 30 will be 19.3. This one will be negative 100 plus 60 times sine 50. This one will be negative 54. So finally, F2 as a vector equal X component 43.6, I, Y component negative 19.3 J, Z component negative 54K. If you are looking for F2 as a value, one value equal square root for 43.6 square, 19.3 square, 54 square. So I can figure out F2 as a value, as one value, scalar value. Square root for all of this stuff equals 72. If you are looking for what is the cosine alpha, what is the cosine beta, what is the cosine gamma for this force, okay, equal X component 43.6 divide 72. Y component negative 19.3 divide 72. Z component negative 54 divide 72. Do you remember, guys? Do you remember cosine alpha equal fx divide f. Cosine beta equal fy divide f. Cosine gamma equal fz divide f. So I can figure out the angle of alpha, beta, gamma for force F2. Just to remind you, in this problem, we are looking for magnitude and coordinate direction angles, alpha, beta, gamma for F2. This problem exactly the same like this problem. The same, nothing else, except the R resultant value, the resultant value as a vector, or the resultant force as a vector. We have three components: negative 300I, positive 650J, positive 250K. So please, like if here, if F not given, the angles are not given, go ahead and assume this F as Fxi plus Fyj plus Fzk. For this one, F1, go ahead and break this force to three components. Finally, summation all of or X component equal X component of the result. Summation of all Y components equal Y component for the result. Summation of all Z component equal Z component of the result. Guys, do you have any more question? This one is piece of cake. This one is piece of cake also. The main idea, break forces to components. Summation of all X component equal X component of the resultant. Summation of all y component equal y component of the resultant. Summation of all z component equal z component of the resultant. Our topic today, I believe, nothing new. We have 3D forces, but these forces are in equilibrium. In equilibrium means if you have a system of forces in 3D in equilibrium, that means summation of all x components equals 0. Summation of all y components equals 0. Summation of all z components equals 0. That's it. We are done with this week. But only if the forces are in equilibrium. For example, this one. We have F1. Anybody can tell me what is the value of F1 as a vector? You don't need to break anything because F1 in the positive y direction. So we have 0i, positive 400j, and 0k. Here is F1. For F2, F2 is very easy. F2 in negative direction of z. So we have 0i, 0j, negative 800k. For F3, F3 is coming from this point, which is 0, 0, 0, to this point, which is what? Negative 2, negative 3, and 6. Here is the origin. So I would like to go back negative 2 in x, go back negative 3 in y, and go up positive 6. So I can figure out F3 as a vector equal F3, which is 700, time second point minus first point. So negative 2 minus 0, I. Negative 3 minus 0, j. Positive 6 minus 0, k. Divide 2 square, 3 square, 6 square. So I can simplify this expression. This one negative 2i, negative 3j, positive 6k. Divide how much? 4 plus 9 plus 36 plus 7. Divide 7. So this one will be negative 200i, negative 300j, positive 600k. What about F? Nothing is given. Nothing is given about F. What should I do? You have hint here. You have a hint. If F is nothing is given about F, go ahead and assume F as a vector equal Fxi, Fyj, Fvk. All forces are broken to 3 components: F, F1, F2, F3. Nothing else. Remember, these forces are in equilibrium. So x component plus x component plus x component plus x component equals 0. So I can say 0 plus negative 200 plus fx, x component from each force. All of them equal 0. So I can figure out the value of fx. Y component plus y component plus y component plus y component, all of them equal 0. So 400 plus 0, negative 300 plus fy equals 0. I can figure out f of y. Z component plus z component plus z component plus z component equals 0. So I can figure out the value of fz once you get fx, fy, and fz for force F, I can get a value of F and angle alpha, beta, gamma. So the only thing new today, if the forces in 3D are in equilibrium, that means summation of all x components equals 0, summation of all y components equals 0, summation of all z components equal 0.